Hello. In this example, we need to look at the domains for all of these function operations. You should recall that if I have two functions f of x and g of x, the domains for any of the function operations, I have to find the intersection between the domains for f of x and g of x. Now, f of x is just a polynomial function, and all polynomial functions have the domain of all real numbers, negative infinity to infinity. G of x, however, is a radical, and radicals limit the domain, at least even radicals. Now, this is a 2 right there, meaning that's an even radical. To find its domain, what you do is you take whatever's underneath the radical, say 2x minus 1 in this case, and make it greater than or equal to 0. Then you solve for x. You'll add 1 and divide by 2, and that'll give you x is greater than or equal to 1/2. Notice I didn't need to flip the direction of the arrow because I never multiplied or divided by a negative. Now this is the domain, and in interval notation that would be 1/2 to infinity for g of x. Now I'm going to go ahead and draw a little bit of a number line here. Well, two number lines in fact. Okay, so the top one will be f of x, and the bottom will be g of x. Now, f of x is all real numbers, which means everything here, including the arrows. G of x, however, means I start at 1/2 and go to the right. And I keep going to the right. I also include the 1/2 using a square bracket. Now the question is, where are both of these true at the same time? In other words, if I was to put these on top of one another, where would they intersect one another? And that would be 1/2 to infinity. Therefore, the domain for A is 1/2 to infinity, because it's simply the intersection there. The domain for B is also 1/2 to infinity, because A, B, and C are guaranteed to have the exact same domains. And again, C, 1/2 to infinity. Letter D, however, introduces a bit of a wrinkle, because I'm dividing by something, and that means I can never divide by whatever that is. So in this case, the denominator 2x minus 1 cannot be 0. So, solving for x, I get x is not equal to 1/2. Now notice that this is effectively this right here, just I can't use 1/2. So, the domain here is actually going to be 1/2 to infinity, excluding the 1/2.